Oh. Okay, hello everyone. You can go ahead and start this poll. So use your QR code from your camera. Zoom people, you can hear me, right? Without any problem. Okay, good to know. As you know, this is not graded. Just try to be honest and whatever you know. Very slow. Okay, so try to complete in next 30 seconds. Okay, so let's see the result. All of you done? Just raise your hand if you're done. Okay, I see. Cool. Your responses. So we have only 98 responses so far. Okay, so I think many of you are still doing that. Just submit whatever you know. So do you clearly see the screen or is blur? Is it clear? Okay, when I went there, it doesn't look clear, sharp, right? Yeah. Okay, so whatever we have so far, let's see the answer. So first question, which of the following is valid in C? I see majority of you know about this, that this is valid. This is not valid. This is kind of Python syntax. This is not valid. You cannot write then, right? So you don't have to write then. So the syntax is you write if you put a parenthesis. So this part of the syntax, you have to put a parenthesis. And inside that, you write the condition using relational operator. And then you have something to do based on the condition. Okay, so let's go to the next question. What happens if you forget the curly braces in C when writing if else? So we'll throw a syntax error? No. Curly braces is not important. Okay, when you do this, if you have multiple lines that you want to be part of the if, then you put brackets like this. But if you do not put bracket, it will just process the immediate next line that is part of if. So only the first line, first statement after the if will be processed. So majority of you are correct, but still I see many students answered something wrong. So indentation decide which statement. This is not C programming. Okay, this is in Python programming, not in C. The program won't compile at all. This is also not correct. As I said, this is optional. You don't have to use bracket. Use bracket if you want to include multiple lines inside if. That is the main rule. Okay, which are, so majority of you are correct. So I'm not spending time on this, but yeah, so you use relational equal operator. What would be the output for the following code? I'm sure many of you, only 37% answered this correctly. Okay, so it will always print hello. Why this will always print? This is not a compiler error. We saw this in our last lecture. Okay, so what will happen? It will read like this. If you write, so what operator is this? Assignment operator. This is not relational equal operator. Okay, so what it does, it assigns 0 to x. So x becomes 0. X was already 0. Now x again becoming 0. No problem with that. Now if 0, it is becoming if 0. Remember, in C programming, 0 is false. All the other numbers are true. Okay, so if 0, it means if false. If false, you don't do the things that is immediately after if, right? You go to the else statement in that case. So if false, don't do this because this is false. You go else and print hello. Got it? Okay. I explicitly mentioned this multiple times in our last lecture, and many of you still did the same mistake. Fortunately, this is not a real quiz. If it was real quiz, and if 50% of you fail, don't blame me. Okay? Because I said this in the class. So you have to pay attention. Okay. What would be the output for the following code? Same example, right? Int x equals to 5. if X print high, so it will print high. Why? If true, 5 is not 0, right? So 5 is a true number. So if true, do this, because true is, so that is the process of if. If this is true, then do this. So it will print high. Okay? So this is not error. Okay. Let me ask you a question. Let's see how many of you can answer this. Have you seen any example in our last lecture using this syntax? And if yes, what was that example? You should remember that example.
If that's 0, that's false. If that's false.
Yeah, so that is general, but specific example. I was giving an example of some kind of grocery. Do you remember that? Am I in the right class? I'm just. Who can save the whole class? Exactly, he saved you, so all of you should treat him. Okay, so we have learned an example. We have gone through an example, taxable. Okay, so you buy something from Walmart, for example. Some items are taxable, some items are not taxable. Okay, if it is taxable, then we add a tax with the price. If it is not taxable, we just say, okay, pay the original price. Okay, and during that time, we have used this syntax. We spent pretty good amount of time on this syntax on our last lecture. And that was actually a pretty good example that shows, and also this is very common way of writing code by programmer. So don't say this is error. If X, it means if this is true, do this. So if it is taxable, it will not be 0. So you add tax with the price. Else, pay the original price. Okay? You have to review the things. Remember, this is pretty alarming. I am thinking, I'm predicting if you study like this, your quiz will be horrible, guaranteed. Okay? My quizzes are known to be good in terms of the questions. It's not like multiple choice. You have to answer this directly by writing. Okay? And if you do not know how to do this, what is going on and so on, you will not be able to answer question. And in this class, you came here to study, to learn, right? So make sure you pay attention and review anything. I keep saying the same thing. When you come to a class, make sure you review the things you studied in the last lecture. I'm sure most of you have already used if-else in your programming in Python or Java or whatever. But see, many of you could not answer this simple question that is in C. So you have to study well. Let's go to the next question. What will be printed by the following line of code? Only 41% students are correct. So this code will print x is 0. So x equal to 0 is true. So it will print 1. X not equal to 0, it will print 0 here because this is false. X is less than 5. So 0 is less than 5. This is true. So it will print 1, 0, 1. Okay. I see some of you have written true, false, true. This is partial error, but this is not in C. In C, if it will be printed, it will not print true. It will print 1, either 1 or either 0. Got it? And this type of code, whenever we started learning if else in our last lecture, we started writing this code. First code we have written something like this in if else. Because these are Boolean expression. This Boolean expression will result in either true or false, and true is 1, false is 0. It will be printed like this. Okay? I see a lot of different types of answer, but yeah, this is the right answer. What would be the output of this code? Okay, so our score is 95. This is true, it will print A greater than. This is also true, it will print B greater than. This is also true, it will print C greater than. It will print A greater than, B greater than, C greater than. So 92 of you are correct. But yeah, so because individually they are true, so this is true, it will be printed, this is true, this will be printed. See, this if and this if, they are independent if. The later if does not depend on the previous if in this case. Now what I did, next one, I used else if now. If you use else if in this case, it will print A grade than. So 78% correct, so that is actually boost from the previous example. Yes, A grade than, it will print only this one. Because this is how else if work. In case of else if, remember I gave an example like you have different floor of a building and you're trying to access a particular floor. So every floor you're going, you have a key, you try to unlock it. If you are able to unlock a particular floor, you will be able to go to that floor. You don't go to any other floor from there. Okay? Otherwise, if you fail to unlock a particular floor, you go to the next one, you go to the next one and keep trying to unlock a particular floor. So here if it is 95, this is true. So it was able to enter that floor. It will not go to any other floor from here. All of them will be skipped because these are all dependent on each other, else if, else if. Okay. What would be the output of this code? Okay, so let's see who fall into that trap. Okay, some of you fall into that trap. Yes, so if his score is 85, this is not true. So as a result, it will not print A grade than. Then print a B grade. This line is independent line. This line does not depend on if, see, because there is no bracket. If you want to include both of them as part of this if, you have to put bracket. Because there is no bracket, this line becomes independent. Got it? So what will be printed? B grade than done. So answer is B grade. What is that? Let me double check. Oh, there is no C, right? Yeah, I have added. So the answer will be, there is no right answer, right? There is no right answer. Okay. Yeah, so the last one is closer because I copied from the previous question, I will keep the C. Okay, so answer will be B grade than done. Got it? Okay. So we're done with this question and let's go back. Let me correct this so that I don't have this problem anymore in future. Okay, so raise your hand if you think this review was helpful. Okay, great. But see, many students will complain around the end of the semester. He spent too much time on simple if else. But see, if I do not spend this time, all of you will fail in the test because if I ask this kind of questions, okay, I cannot answer this question anymore, right? Okay, make sure to practice. Let's go and continue learning if else. So if else part 1 is kind of complete. Let's just briefly review. We have also gone through nested if else. And we have seen why indentation is important. This exact same code written in this way, output and everything is same. What is the difference? The difference is here I have indented my code properly. Here I did not indent anything. So as a result, the result is same, but the code reduced the readability. It will be very difficult to read this code to understand what is going on compared to this code. But both of the codes are exact same. Just no space in this code. Okay? We have also gone through this example in our last lecture. Remember Adam's grade and Jones' grade? Okay. So I printed if grade of Adam is less than grade of John, who got better grade? Adam or John? Adam also actually got better grade. So why? This is less than. Sometimes less than is better, right? When? If it is letter grade, because A grade is better than B grade, right? So A is smaller than B. So We are talking about letter grade. So if letter grade A is better than B grade, so that's why if Adam's grade is less than John's grade, it means Adam got better grade because his letter grade is better. Okay, cool. Write a code, takes an integer. So take an integer input and determine whether the number is an even number or odd number. How many of you have written this code before? Okay, pretty classical code for if else. Let us write it in C programming. Okay. So how to check a number even? Modulus, right? Any integer mod 2, if you divide any integer by 2, if there is no remainder of the division, then this is an even number, right? 4, 8, 6, if you divide them by 2, there is no remainder of the division. If there is a remainder of the division, the remainder will be either 1 or 0 because you are dividing by 2. So if the remainder is 1, this is an odd number. If the remainder is 0, that is even number. Okay, there is the whole idea. So if you write this code, let's write with this one. So I'm receiving a number, integer int and scanf %d and okay, so now I'm printing if and mod 2 printf. Tell me what should I write in line number 17? Should I print odd or should I print even in line number 17? So raise your hand if you think I should write even in line number 17. Raise your hand if you think I should print odd in line number 17. Many of you didn't raise hand. So you're for even? Okay. If you're not sure, raise your hand if you think I'm not sure. This is perfectly fine. Okay, good job. So see, raise your hand if you agree that if you mod any number by 2 and if the result is 1, that is an odd number. Do you all agree with that, right? Because any number mod 2 equals to 1 means that is an odd number. So I'm writing n mod 2. So the result of n mod 2 either will be 0 or 1. If n mod 2 is 1, it is becoming, it will read like if true because 1 is true, right? So if true, what should you print? Odd. Why? Because n mod 2 is 1, right? If n mod 2 is 1, it will read like if 1. If true. So if true, if you have true in this place, then it will be printed. Else, printf even, otherwise it is even number. Okay, now if you run the code, so what is the problem? Line number 14, missing ampersand. Make sure to practice how to write ampersand, okay? Because many students come in the class, they call me, can you help me how to write ampersand in the test? Okay, make sure to practice how to write this symbol in the exam, right? Okay, so run the code, give a number, 85. 85 mod 2 is 1, it will print odd. Run the same code, write 96, printing even, because 96 mod 2 is 0. If 0, if false, then print even. Got it? Now you say, I don't like to write like this. Can you write the condition? Okay, if you write the condition like this is also fine. Even if n mod 2 equals to 1, print odd, otherwise print even. This is also fine. That is also fine. This is pretty common way of writing. if you write this same code. If you write 0 here, then it will be even here, and this will be odd here. So now if n mod 2 equals to 0, if it is true, then even, because the mod is 0. All right. So if you see 86, this is printing even because this is true. Yeah.
Does it take the same amount of time compiling?
The previous one was faster because it doesn't have to compare two relational operator. Okay, so we are done with this example. Let's go to the next one. So this is that code. Here I'm writing in this way. This was very similar to one of the poll question. This is an example of using else if. Let me directly show you instead of writing the code. So here is the code. If you observe here carefully, I'll ask you a couple of questions. Enter your total points. You got the number. Then you're checking if the number is greater than or equals to 90, you got A. If it is greater than or equals to 80, you got B, you got C, you got D, and so on. So this is just using this grading scale. If someone got this A, this is B grade, this is C grade, this is D grade, and this is F grade. Now get ready to answer some question. Here I'm entering 95. What will be printed? Raise your hand if you think it will print you got A, you got B, you got C, you got D, all of these 4 lines. None of you? Raise your hand if you think it will just print you got A. Okay. Why it is doing that? Isn't 95 greater than 80? Then why it is not printing you got B? Now I am confused, right? Yes, seems 95 is greater than 80. It should also print B. So now raise your hand if you think you change your mind. Okay, some of you changed my mind. Change mind by okay. Yeah, so there's a problem. No problem actually. Because this is using else if ladder. If you get 95, this is true. So your code will print you got A. Because it was able to enter that floor, it will skip all of this part. So this will be skipped. This will not check this anymore. Got it? So as a result, 95, even this is true, but your code will not check this to check if it is true or not. Your code will not go to that place at all. Got it? Okay. Now if I say 85, it will try to go here. This is not true. Then it will go to the next floor, right? So it will try to go to all the floor one by one and try to enter in that floor. Now in this floor, is it true? Yes, 85 is greater than 80. So it will print you got B. It was able to enter here, it will skip the remaining part of else if ladder. Got it? So this is how else if ladder work. Because you know how else if ladder work, you were able to write this code in this way. Otherwise it is very confusing. Come on, you're checking if number is greater than or equals to 80, but it will not go to this place if it was able to go to that place. Okay, so you know how else if ladder work, that's why you brought this logic. However, if you just remove this else, now it's completely different story. Now if you enter 95, what will be printed? You got A, you got B, you got C, you got D. Got it? Clear? Okay. Remember, if you have any confusion, raise your hand. Yeah. Where?
If you look at the U got B, it is equal to A.
Okay, that's a good finding. Okay, so it should be what? Yeah, put 60, right? So you should put 60. Yeah.
Also, you have to put brackets for else if or no?
Okay. So else if you have only one line, you can skip using bracket. But if you have multiple lines under that, you have to put bracket. Okay. So let's say you want to say you got A, congratulations, and you got this, and so on. So you want to have a lot of printf, then you put bracket. Okay. Cool. Let's see some common mistake while using if else. Not using relational operator like if x equals to 5 instead of writing. So sometimes you do mistake like this if x equals to 5, but you are thinking to write this one. So you probably not be able to sleep that night because why your code is not working, because you are doing it properly, but you didn't do it properly. You have to do it this way. Okay. Sometimes you also pretty common mistake, you do not put parenthesis. If you do not put parenthesis, this is not right, you have to put parenthesis. Another pretty common problem is if you write this and you put semicolon here, do not put semicolon here. That doesn't make sense. If you put semicolon here, what is the problem? It will make the following lines independent because you actually ended if right away. Okay. Then skipping brackets, if you use bracket, this line is not part of this if. Okay. If x equals to 5, only this line is part of the if, this is not part of the if. If you want to make it part of the if, make sure to bracket. That's all about this particular topic. Let's go to the part 2. In the lab today, you have actually gone through some part of part 2. So it will be a bit of review at the beginning. So decision control structure if-else part 2. What we'll be learning in this? We'll be learning Boolean logical operator and or not. Then also revising our grading code, the code we have just seen. We'll update that code. Then we have some other example, and also we'll be learning conditional ternary operator. We'll also learn actually something called short circuit evaluation and so on. So let's start. So sometimes we have to check multiple conditions at the same time. Example, let's say I want to check, is it Monday and do you have a test today? Okay, do you have a quiz today? So question, if I say today is Monday and we have quiz today, it's not true. We don't have quiz, so don't get scared. Okay, so why this is not true? Isn't it Monday? But the next statement is false, right? So if you use AND to join two conditions, both of the conditions have to be true to say the whole statement true. If any one of this part false, the whole statement is false, because my first part is true that today is Monday, but my second part is false because today is not a quiz day. Got it? If I say today is Monday or we have quiz today, is it true or false? True. Then let's have the quiz. Okay. So today is Monday, this is true, but the other part is not true, but it doesn't matter because we have used or. If I say or, if one of them is true, the whole statement is true. Got it? Oh, because either one of them true, so the whole statement is true. So in C programming, we use AND operator. You have to write 2 ampersand if you want to say AND. So you have two expressions. I say today is Monday. This is expression 1. And we have quiz today. This is another expression. If both of them are true, the result is true. So in our case, this is true and this is false. Okay, let me erase this a little bit. So in our example, today is Monday, this is true. And today is quiz day, this is false. So true and false is false. Okay? Similarly, we have OR operator. OR is pipe operator. So use two pipe symbol like this. So there's a symbol like this in keyboard. Remember to use two of them, not one. Next one is NOT operator. This is called NOT. NOT is a unary operator. We'll see that. So to see the summary, don't start reading the slide as I said. This is called truth table. True and true. Sorry. Yeah, true and true is true. True and false is false. So see, if you use AND operation, if any one of them is false, the result is false. This is true only if both of them are true. Similarly for OR, if both of them are false, this is false. If any one of them is true, this is true. One of them is false, this is not a problem if another one is true. If both of them are false, then this is, if I say, for example, I say today is Wednesday and we have quiz today. Sorry, today is Wednesday or we have quiz today. Is it false or true? False, because today is not Wednesday. Also, today is not a quiz day. So both of them are false. The result is false. Okay. Now, let's go back to our grading code. So I'm going back to the grading code. Let's write the code here. Let's have some more space. More space. Okay. So int score, printf, enter your score, scanf, %d, ampersand score. So I got the score. Now I'd like to check if it is A, B, or C. So if score is greater than or equals to 90, let's have something. Printf, you got A. Printf, great job. Okay. Else if. Okay. So the code we have seen before. This was the code we have just discussed few minutes ago. In this code, it was a bit confusing because you have used else if it was working. But can you make it more explicit condition like this? See, I'm writing just if now. If the score is between 80 and 90, that is B grade. So how can I write that condition here? How to check a number in range, that if it is within this range? So let's say someone got 85. It should be B grade, right? So if score is greater than or equals to 80, is it B grade? No, right? Because anything greater than or equals to 80 is not B grade. For example, 90, 95, that is A grade, not B grade, right? So what is the other condition I should put here? It is fine if you are more than 80, but you have to be less than 90. So I put and score is less than 90. If both of them are true, it means you are really a B grade. Got it? So printf B grade. So similarly, if you write if score is greater than or equals to 70 and score is less than 80, printf C grade. Finally, I'm writing else. In all other cases, I say else printf f grade. Let's say 60 is less than is f grade, for example. So carefully observe this code. This is fine, will work. If I run the code, printf. Okay, so enter your score. I'm giving 95. Carefully observe what is happening. This is important to understand. You probably see, oh, it is giving me right answer, but you should know why it is giving you right answer and so on. And what it's really doing. Okay, give me a moment. I got an urgent call, okay? Okay. So if I enter 95, your code will go to line number 11, right? Is it true? Is 95 greater than 90? Yes. So it will go inside and it will print these two lines. My next question is, would it go to line number 17? Yes, because this is an independent if statement. This is not else, right? So it will go to line number 17. After going to line number 17, it will check this part first. It will check the left one first. Is this true? Yes, 95 is greater than 80. This is true. When this is true, your code will jump to here. It will check. Is it true? No, 95 is not less than 90. So what happened? True and false. Result is false. If false, don't do this. Right? Because this is false, your code will not print B grade. Next, it will go here. Is it true? Yes, because 95 is greater than 70. Go here. Is it true? No. True and false. False. Don't do this. Would it print F grade? Yes, it will print F grade because this else is part of this if. If this is not true, it will do and go to F grade. So let's run it. You got A. Great job, F grade. Got it? Okay. Now, of course, if you don't want to print this, have another condition. If score is less than equals to less than 70, F grade. Okay? Now if you run this, it will work probably. So 95, A grade, great job, and it's not printing. Yes, go ahead. Okay, the previous example. Okay, let's go back. I'm pressing Control Z so that I can go back to this here, right? So see, this if, this block, they're independent from each other. However, this else depends on this if. Exactly. So if it is true, then it will do this, it will not do this. Because this is false, it will do this. Okay. Next question is, it's not a good design of the code. Why? Because if someone got 95, he got A grade, we don't have to check this at all, right? Because if someone got A, it will not be B, C, D anyway. So how can we make this code better? Just use else if. right? If you use else if, now what will happen? If one of them is true, it will not go to the other one because other one will not going to happen anyway. Got it? Okay. Now we'll learn something interesting. Someone got 75. Okay, so let's run it. I have entered 75. So you got 75. Is it true? No. Your code will go here now, right? Is it true? Now something interesting will happen. Because this is not true, your code will not check this anymore. Because it's useless. Because you're using AND here, right? In case of AND, if something is false, the whole result will be false anyway. Why to keep checking something is true or not, right? Make sense? This will be happening here. This is called short circuit evaluation. So you learn a new concept. Short circuit evaluation. So what is short circuit evaluation? Read what I'm saying. So short circuit evaluation is if you use AND or condition, your code will try to make decision as soon as possible. And it will skip subsequent checking if it is not necessary. Got it? So if it can make a decision early, it doesn't need to keep checking. Example here. If my input is 75, whenever your code finds that 75 is not greater than 80, it doesn't need to check this anymore because this is false anyway. Because we have used AND operation. Got it? Okay. Same. It will go here. Is it true? 75 is greater than 70? Do you think it will check this? Yes. Because it cannot make decision until it finds all of them at this moment. Why? Because one of them is true. I cannot say this is completely true until I check the other condition. Make sense? Why? Because I have used AND operation. In case of AND, all of them has to be true to say this is true. During this checking, if I find something is false, I skip the remaining because this is false. Got it? This is the whole idea. This is how short circuit evaluation works. It also works for OR. Can you guess in case of OR when it will stop checking? Whenever it finds something true, it doesn't need to keep checking because it will be true anyway because you are using OR. Make sense? Because in case of OR, if one of them is true, I don't need to keep checking because this is true anyway, because even all of them are false, this is still true because this is OR. When it will need to check all of them, if it keeps checking false, 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 false like this, because all of them has to be false to decide if it is false. This is short circuit evaluation. Got it? Very important concept and very useful in many different coding. Okay, so we are done with this particular example. Now let's see another example of short circuit evaluation use case. For example, you want to check if the modulus of a number by another number is more than 2 or not. Okay, so let's try this. Int x, y. So I got two numbers. I'm printing printf, enter x and y to check if x mod y. Remember, if you want to print mod, you have to put 2%, okay? Okay. Now I'm see what I'm doing. If, oh, let me see scanf, %d, This example is not in the slide, okay? Address of X, comma, address of Y. Now I'm checking if X mod Y greater than 2, printf it is greater than 2. Else printf it is not greater than 2. Okay, so carefully observe, this is a very interesting code. I'm running the code. Enter X and Y. I'm giving find space 0. What does it mean? We are trying to divide 5 by 0 and find what is the remainder. Can you divide any number by 0? No. What will the output? Let's see. It's not printing anything. It crashed. See? Exit code 136. So it could not go to return 0 this line. It just got out from this line. Okay. Now, what is the problem? You want to check that Y should not be equals to 0, right? You are writing something like this. If X mod to Y greater than 2 and Y is greater than 0, then you want to do this. Because you want to check that Y has to be greater than 0 to do this division before doing this division. If both of them are true, you want to print this. Would it work? Run it. 5, 0. It still doesn't work. Tell me, what should I do now? I need to change something in this code without introducing another line. Let's see who can solve this problem. Because you don't want to actually divide any number by 0. Yeah, go ahead. So you want to change this, put it here. Raise your hand if you agree with him. And this is correct. Why this is working? Because of short circuit evaluation. Why? So you don't want to check this if it is not true. Got it? If this is true, then your code will check this. If this is true, then it will be printed. If this is false, you don't want to divide because this is dangerous. Got it? So now if you run the code, you write 5 space 0. It is not greater than 2. So it is not really dividing this number. So your code actually saved by just changing the order because you know how to use short circuit evaluation in your code. So you have used short circuit evaluation as a feature in your logic. Because if this is false, you know that short circuit evaluation will not check this anyway, so your code will not go here, so it will directly go here. If this is true, run the code, you write 5 space 2. This is not a good number. Let's have 13 space what? Give me a number that will be more than 3, right? No, it is 1, right? Is there a number that will make it more than 2? Okay, so 11 space 3, right? So no. So find a number that will make this true. 7 space 11 and 7. Okay, yeah, that's a good idea. So 11, 7. So see, it is greater than 2. because 7, so 4, the mod is 4, right? So what do you see from here? So short circuit evaluation can be useful like this. Got it? You know, I spent actually at least around 10 minutes on short circuit evaluation. Next class, if I talk about this, so okay, was it discussed in the class? I have no idea what is short circuit evaluation. Don't be like that, okay? And this logic is very useful, especially how many of you have to take computer science 1? If you have to take computer science 1 class, very often we use this logic to prevent potential segmentation fault. Okay? You write logic like this in a line. Okay, so let's keep going. So short circuit evaluation is done. This is another example. Let's try another example, insurance policy. So there's a company called Simple. Okay, very simple insurance company. They don't want to take risk. So motor insurance company insure a driver to the following cases. They will give you insurance if the driver is married. So get married to get insurance. Okay. If you're not married, don't they give insurance to other people? Yes, they give. If the driver is unmarried, then you have to be male and you have to be above 30 years of age. Don't they give insurance to female? They give. If the driver is unmarried, female and above 25 years age, they also give insurance. So they have these 3 policies. If you fall in one of them, they will give you insurance. Otherwise, they will say you are not eligible. Okay, so we have to write a code for this. So if you want to write code for this, how many variables do I need? What do you think? So I need to know the marital status, right? Then I need to know gender, is it male or female? Then I also need to know age, right? So these 3 type of input. So let's write code for this. So I'm writing this code. So marital status and gender will be character, right? So char, gender, marital status. Then int age. So printf. So enter age, gender, M or F. Marital status. What do you write here? Okay, married or unmarried here. Okay, so you have these 3 inputs. So let's take input scanf percent what? Percent D. Next one is percent C, percent C. So these 3 input. I have M percent age, M percent gender, M percent marital status. Okay, so I got the input. So according to their policy, what is the first policy? Married, right? Do you remember the policy? Or I have to show it? Let me take it. So I'm taking the policy and putting on top of my comment. Okay. So number 1, if the driver is married, so what should I write? If MS equals to M, married. What should I print? Print F, you are eligible. Should I use else if or another if? Else if, because if it is the case, you don't want to keep checking, right? Else if, I'm writing if it is unmarried, male and 30. If it is unmarried and gender male and MS equals to, so age, right? Age is greater than 30. Printf, you are eligible. Okay. Next, else if. Last one, right? So unmarried female, 25 years of age. So I'm copying this, putting it here. Unmarried female, 23 or 25. Then also I want to print you are eligible. Finally, else. Printf, printf, not eligible. Okay. So this is our code. Correct? Is there any problem with the code? I will ask you a couple of questions. Let's see. So enter age. So let's say I'm giving age 26, male. Next one is marital status, married. Is it eligible? Okay. So your code will go to line number 18. Is it true? Is marital status married? Yes, it will print you are eligible. It will skip all of this line. You are eligible. So it's actually printing this line number 19. Run the code again. 24 female, sorry, male and unmarried. Is it eligible or not? No. How it will know that? Let's see. Do you think it will check line number 18? Yes, it is fine. Marital status is not, it is actually unmarried. So it will go to else if. Would it check this? Yes. Is it true? Unmarried is true. Would it check gender? Yes. It's still true. It will go here. Is it true? No. True and false is false. So it will not do this. It will go here, check this. Is it true? Yes, unmarried. Check this. Is it true? No. Do you think it will check this? No. Short circuit evaluation, right? So it is finding this is false. It doesn't need to check this. So finally, it will just print not eligible. Okay. Now we play with the code a little bit. So this is a very straightforward code we have written. My question to you is, can I skip this particular condition, marital status equals to you? We can skip that part. Why? Because if it is married, it will go here. If it is not married, it will go here. So you don't have to check if it is not married because it came to this place because it is not married anyway. Make sense? Okay. So see, sometimes you can skip condition like this. Let's bring that back. If you see, I have printed same thing 3 places. Can I have only one printf and put the condition in a way so that I don't have to write printf multiple times? See, if this is true, or if this is true, or if this is true, I want to print you are eligible, right? So how about combine all of this condition in a single line? So what I'm going to do, I put one extra parenthesis here. I'm using or here. Then I'm using cut, paste, or here, cut, paste, done. And I'm removing all of these lines. So see, I have a big condition using or. If this is true, do this. If it is not true, try here. If it is true, do this. If it's not, try this. So if none of them are true, print not eligible. Make sense? So we are combining multiple conditions together like this. So we're done with this example. Any confusion, any question, just let me know. I'll keep going now. Okay, so let's see the next one. We're running out of time actually pretty fast. Not operation. Okay, so not use a unary operator. Unary means you just need only one operand. For example, not true means false, not false means true. Let's say you have a tournament and you have to be 25 years or more older to play in that tournament. So what I'm going to do, I'm going to int age scanf %d and %age. I'm checking. So if you're not more than 25 years, you cannot play with us, something like that. So I'm writing if not age greater than 25, printf you cannot play. Else printf you join us. Okay. So let's run it. Printf. Okay, so we are looking for the age. So let's say I'm giving 20. Okay, your code will go here. Is 20 greater than 25? No, right? So I don't want them. So I say make it true then. So make this whole condition true. If you are not more than 25, then you cannot play. So see, 20 is not more than 25, so you cannot play. So you write the condition in a way, it reads like this. If it is not more than 25 years, but how it is really doing the job? It checks the condition, yes, this is true. This is false. But if I want to go here, I have to make that false true. So I write not true, not false, so it will go here. Got the idea? So this is the use of not condition. Remember, we have written the code for taxable item. If the item is taxable or not, we can also use same concept here. So you can write, remember the code, I'm not writing that again. So you can simply write if not taxable. If the value of taxable is 0, it means it is not taxable, right? So if someone says it is not taxable, they put 0. And you are making that 0 true. Yeah, it is not taxable. Then print, just pay the original price. Got it? Make sure to write this code, okay? You have the code that was using trivial approach. Use not taxable approach as part of practice. Okay. Next, now you know what is not operator, right? Now you'll be able to understand this meme, this one. Okay? So only computer science or people who learn coding can understand this heartbreaking. So she is asking, do you still love me? And his answer was this. Not yes. Okay? So she'll be really happy. Yes, yes, but it's not actually. Okay? Hierarchy of operators. Remember, we have learned hierarchy of operators like multiplication has higher priority than addition in our arithmetic chapter. So in case of Boolean operators or conditional operators, there are also hierarchy. For example, not has the highest priority. Then multiplication, division and mod has less priority. Plus minus has next less priority. Greater equals, these are next less priority. Relational equal, not equal has next priority. And has next priority, or has next priority, and assignment operator has the least priority. Now, very important. I say very important. Okay. I don't have any example in the slide, but I will show you an example. Make sure you follow that example because you have some exercise, quiz-based exercise. There's some question like this, the way I'm showing you now. For example, I have an expression like this. I'm writing 5 or 2 and not 0. So I want to say, what is the result of this expression? Which operation will be performed first? Not. So not 0 is what? True, 1. So the next line will be 5 or 2 and 1. How you got this one? Not 0 is 1. What is the next task? Should I do 5 or 2 and 1? And has higher priority than or. Keep that in mind again. 2 and 1 will be evaluated. Is it true or false? True. So 5 or 2 and 1 will result in 1. 5 or 1 is 1. True or true is true. Got it? I showed you. You don't need many examples. You just need to do on your own. Yeah. Not above 0. Anything equal 0 is false. It could be negative, positive. They are all true. Got it? Yeah. Exclusive OR is a bitwise operator that we don't do in this class. Okay? I teach it in CS1. So you got it? So these are the precedence of operator. Make sure you know this. Who has higher priority and how to evaluate this expression. As I said, there are many examples like this. Sometimes this is heartbreaking to see in the quiz. Many students fail this type of question. Even they practice multiple times. Don't do that. Last topic today is conditional ternary operator. Conditional ternary operator. What is that? Unary operator works with only one operand. Can you give an example of unary operator? Not, right? We just saw that. Not X, not true or false. Is there any other unary operator you know? X plus plus. See, this operator just needs only one operand. Binary operator, X plus Y. Addition is a binary operator. You need 2 items to add. That's called it binary operator. That needs 2 operand to work on that operator. Now, there is something called ternary operator, conditional ternary operator. The operator is actually what? Colon. How it works? It has 3 parts. You have an expression here, let's say E1. Then what symbol? Then another expression E2. What? Then colon, another expression E3. You read it like this. If E1 is true, do E2, else do E3. So this is the equivalent of this line. Example, let's say here, I have 2 variable int a, b. I'm taking input scanf %d ampersand a. See, I'm writing b equals to, this is the conditional ternary operator happening. A greater than b, what? 3 colon 4. How you read it? You read like this. If a greater than 5, b equals to 3, else b equals to 4. So this is exactly their equivalent. So this line is same as processing this. Got it? So you don't have to write if, just write a greater than 5. So for example, going back to our even odd code. So what is that code? Let me see. Okay, so let's say for this code, I want to use conditional ternary operator. See what I'm writing? Age is less than 25. Okay, age is less than 25. What? Print of this colon, printf this. So see, I didn't write if. This is automatically if. If age is less than 25, you cannot play. If this is not true, it will jump here and it will print join us, because it means age is actually greater or equals to 25. Make sense? Okay, so if you run this, it will work. What is the error? Line number 18. Oh, age, yes. Okay, so see, if you write 26, join us. Got it? Next, let's say even odd code. I want to check if the age is even or odd. What I can write? I can simply write age mod 2. Print f. Can you tell me what should I write here, even or odd? Let's see who can get this. It should be odd. If age mod 2 is greater, is not true, right? If it is true number, then it will be odd. Otherwise, it will be even. Okay, so this is how it works. Let's say 58. This is even. So just before leaving, I just don't want to keep it. This is the last example. So you can have multiple condition here. Okay. So see, you can use and or inside this ternary operator. So this is the condition. If this is true, do this, else do this. Okay. Finally, it could be nested, but do not nest it too much. So see here, we have 3 variables, A, B, C. If A is greater than B, true, then do this whole thing, else do this whole thing. And when you go here, you have another of this. If this is true, do this, else do this. Okay, just before leaving, can you tell me if my input is A is 5, B is 10, and C is 7, what will be the value of big?
6.
Okay, let's see. Is A greater than B true? 5 is greater than 10? No. It will jump here, right? Is B greater than C? Yes. So it will bring 6 to big. So big value will be 6. Got it? This is how it works. You should not make it more nested than this. Remember, conditional ternary operator is optional topic. I mean, you don't have to use this. You can always use if else, right? But this is also an option to do. It's a kind of shortcut writing if else sometimes. That's all. We are done with if else topic.
What? You never say the last line. Which one?